These are the notes for 7.4. In 7.4, you explored triangle congruence shortcuts, and you found that some triangle shortcuts lead to congruent triangles and others do not. So this is just a summary of what you learned in this section. You found in this section that ASA, angle, included side, angle is a triangle congruence shortcut. So if I start at this particular angle and I walk, if I look at what's happening here, I have two angles, and in the middle, the sandwich is a side. We also found that side angle side, or side included angle, was also a congruence shortcut. So I have two sides, and then I have the angle that's included in them. So I have the two sides of the angle that are included. We looked at angle, angle, angle. In this case, we do not know that they are congruent. We do know, however, that they are similar, meaning that they are the same image blown up or shrunk down of each other. We then explored side, side, angle, and this is where we have the angle is not included, which means I have two sides. There are two sides right here and right here. However, the angle is not in the middle of those two sides. It's out here. And this is a great picture to show that this is the two different triangles that I can have, that I can create, where I have two sides congruent and an angle congruent that's not included, and result in two different triangles. The next one we explored was side, side, side. So as long as you have three pairs of sides congruent, we have congruent triangles. This next one is a variation on angle, side, angle. And the reason for that is that if I know that these two angles add up to the same as these two angles, I have to then conclude that the third angles are congruent. So I then could also conclude that, which then would allow me to say angle, side, angle. And the last one is hypotenuse leg. And you're going to want to remember that this one's very similar to the same idea as the angle, angle, side. Because these are right triangles, once you have two of the legs, you can always say that the third one must be congruent. And that's because of the Pythagorean theorem. So then you could say that this is true by angle, side, angle. Whoops, I'm sorry. Side, angle, side. Side, angle, side. You could also say that it is true by side, side, side. So the AAS and the HL are special cases of proofs of conjectures that I can use to say that two triangles are congruent.